In this program, we are going to learn what are all the various methods of geophysical well logging. So, what is geophysical well logging? It is a systematic procedure of collection of information about the subsurface formation penetrated by a borehole, that is by a well, by rising and lowering of set of probes. So, you can see here the various tools, they are all known as probes, which are inserted into the existing borehole. The main purpose of allowing them to go into the borehole is to gather information regarding the geological formations. That means, at the end of doing this, we will be able to understand the various geological formation, how fractures are distributed beneath the surface, and how capable the formation is in yielding water or oil. So, this is the regular setup which you see here. That means, there is a borehole. Through the borehole, the sonde, which is nothing but probes, set of probes would have been attached in the sonde, which is lowered through a pulley, which is connected to a winch stationed on a small truck or jeep. And the jeep also has got a recording system, that is, usually it is a digital recording system, which will try to collect all the information from the sonde through the cable that is attached to the recording system. On the whole, various subsurface geophysical logging methods can be divided into two major groups as open hole logging and cased hole logging methods. That means, here in the first case, logging is carried out in a borehole without any casing pipe, which means the borehole is open. Normally, in the case of solid sedimentary rocks, we need not provide any casing pipes, whereas in the second method of logging is possible in the case of even the wells that are provided with casing pipes. In the first case, logging will be possible by electrical, nuclear as well as acoustical methods. In the second case, we will not be able to go for electrical methods, because if you provide a steel casing, that will interfere with the measurement which we are going to make. Hence, normally in the cased holes, only nuclear logging will be possible. The various geophysical well logging methods can be divided into these groups like electrical logs, radioactive logging, caliper logging and other methods of logging. But in this program, we are going to concentrate more on electrical logging methods. Electrical logging methods can again be divided into number of groups. As you can see here, the first one is the self potential logging method and the second one is known as resistivity logging methods. We will see one by one. The first one is known as self potential logging method. What we are going to do in this? We are going to measure the naturally existing electrical potential that are bound to be present in the various geological formation will be measured in the self potential methods. how electrical potentials are there in the natural formations. There are the geological formation comprise of various minerals, especially clay minerals. They have different moisture content, due to which naturally some electrical potential will be present in all the geological formations, which we are going to measure in the self potential method. How this is measured? Here measurement is done with a electrode which is sent into the borehole. Electrode is nothing but a conductive metallic body, and another electrode is hammered into the surface of the earth, as you can see here in the picture. One electrode on the surface, one electrode inside the borehole, and the borehole will be normally filled with a drilling mud. Because of this, the natural potential that exists in the formation here is measured between these two electrodes, and the signal is recorded by the digital recording unit, as you see in this picture. That means the natural potential that exists here in the formation is measured. Here if you see, in the case of coarse sand, the potential will be normally on the negative side, whereas finer sediments, as I was telling you, clay and silt and shale formation that are having very fine grained sediments will are capable of producing higher amount of self potential. Hence, wherever we have coarser formations, we will have negative potential. Wherever we have finer grained sediments, we will have high positive potential during self potential logging method. This is thus helpful to us to differentiate porous and permeable rocks from non-permeable clay and shale formations, which means you may wonder that during drilling itself we will come to know of various formations, but during drilling there are lot of disturbance which we create during drilling. At the time while we are drilling at 120 meter, the sample which we are collecting would have been from 100th meter. Hence, we won't be clearly knowing how the various data are located beneath the surface. At the end of carrying out self potential logging method, from the self potential log, we will be able to clearly demarcate porous formation and less porous formation. Hence, we will also be able to define the bed boundaries, and we will also able to correlate the various location of various beds, and we will be able to qualitatively indicate the location of various beds. That these are all the uses of self potential logging methods. So, you can see a example log obtained in a formation which is shown on the right hand side, where the formation consists of shale formation, sandstone which is a coarse grained formation. On the left hand side you can see the self potential log obtained. So, here the deflection is towards the left hand side, that is to the negative side, indicating permeable beds. That means very coarse grained formation. Here also you can see we have sandstone which is nothing but a coarse grained formation. Because of that, the self potential log deflects to the left hand side. Thus, leftmost deflections, all the leftmost deflections indicate coarser grained sediments and formation, whereas the right deflection, the rightmost deflections on the self potential log is characteristic of shale or any other fine grained material. Something like shale or clayey formation will be indicated by a deflection towards the right hand side of the log. So, these are all the applications of self potential logging methods. Then the second group of electrical logging methods is known as resistivity logging method. Resistivity of the formation depend very much again on the grain size of the formation. That means, here rather than using only 2 electrodes, in the previous case we had used only 2 electrodes because we were measuring the natural electrical potential, whereas in this case we are going to make use of 2 additional electrodes to apply the current into the earth, and the potential developed due to that will be measured between the 2 other electrodes. Generally, as you can see here, the resistivity of the formation depend on the grain size. Coarser the grain size, higher will be the resistivity. Similarly, permeability of the formation will also increase with higher the resistivity, because when the grain size is higher, the porosity will be considerably less, due to which the amount of water that is present in the coarse grained formation will be less than that of the water that is present in the clayey formation. Because more water is there in clayey formation, it offers less resistivity. When it offers less resistivity, that also indicates to us that that formation is not capable of transmitting water, which is the measure known as permeability. Hence, formations which are showing low resistivity are bound to have lower permeability. There are number of ways in which these 4 electrodes can be arranged in the borehole. Some of the popular methods of arrangements are known as normal log, lateral log, and lastly micro log. We will see one after another. In the first case, normal logging method, one of the electrode, that means n electrode, is kept at the surface or at some distance from the other 2 electrodes, somewhere away, somewhere in the top of the borehole, and the entire zone is energized as a thick cell with the presence of 2 electrodes A and M here. With the help of this arrangement, that means you can see one of the electrode, current electrode, is kept at the bottommost point of the borehole, another current electrode is at the top through which we are energizing, and 2 potential electrodes, one potential electrode is kept within the borehole, another one on the top of the surface through which we are measuring the potential. This is one kind of arrangement. If you use this, we will be getting a log something like this. That means, what does it indicate? This is the depth of the borehole. That means, we will be lowering the sonde through the borehole like this slowly. The sonde will get us a digital data between depth versus resistivity. So, this is the resistivity, this indicates the depth of the borehole. Here it is 1700 feet, here it is 6700 feet from the ground surface. If you look at this normal log, you can see the deflection towards the right hand side. As I was telling you, higher the resistivity, coarser will be the formation, as you can see here. So, probably this particular formation may be sandstone. When the resistivity is less, that particular formation, that particular zone may comprise of fine grained material such as clay. Compressed clay is known as shale. So, this is how we will be able to make interpretation and determine the nature of formation that is present beneath the surface with the help of normal log. Then the next second method under electrical resistivity is lateral log. Here there is a slight change in the method of arrangement. Here one electrode is kept much away from the other 2 potential electrodes, whereas in the previous case, if you recollect, current electrode is at the bottom, then we had one potential electrode in between, another potential electrode was at the ground surface, whereas in this case both the potential electrodes are kept at the lowermost part of the sonde and another current electrode is kept at greater distance. Then the next current electrode